Good day to all of you. Today we shall discuss on Model Question Paper 1 with effect from 2023-24 CBCS scheme of the subject Digital Design and Computer Organization with the subject code BCS302 for third semester BE degree examination. In this question number 5b, explain the basic operational concepts of the computer with a neat diagram asked for 8 marks. Here we have to consider this diagram which shows the connection between processor and the memory. A computer has processor which processes given information. So to process the information, it will be given instructions. So computer also has memory in which data and needed instructions or programs will be stored, and those will be processed by the processor. For that, the processor different parts are MER, that is memory address register. So whenever processor wants to communicate with memory, which memory location it wants to communicate for either read or write operation, it will place that address in MER, and that will be put on address lines in the bus, that is external memory bus. So hence that memory location will respond. Next, MDR, memory data register. If processor wants to do memory write operation, it keeps that data in MDR, and on data lines in the external memory bus, it will be sent to that addressed memory location. Then on control lines, write signal, that is control signal, is sent to that memory, and hence the sent data through MDR on data lines to memory, it will be written into memory, means it will be saved into that memory location. This is how processor does memory write operation. Similarly, it will do read operation, then memory will put the data on data lines in the external memory bus, and control signal will be given, then read signal. Hence data will come from memory into MDR, and from there it is taken into register. From there it will be given to ALU of the processor. Okay. So this is PC, program counter. It always stores the address of next instruction whenever the processor is executing a program. IR, this is instruction register. Whenever a word is fetched from memory, if it is instruction, it will be loaded into IR. These are set of general purpose registers R0 to Rn-1. They are used for temporary storage of data during execution of a program. This is control unit that generates control signal and sends to all different parts of the processor so as to control and coordinate their activities. ALU means arithmetic logical unit, which does the actual arithmetic and logical operations needed for processing the information. Apart from this, processor has some special registers like index register, stack register, and accumulator. The different parts of processor are internally connected through internal processor bus. This is external memory bus. So inside all the parts through which lines they are connected, that is called as internal processor bus. The activity of computer is always governed by instructions. To perform a given task, an appropriate program consisting of a list of instructions is stored in memory. Individual instructions are brought from memory to processor, which executes specified operation. Data to be used as operands are also brought from memory to processor. Next, we shall consider how this example instruction add LOC, R0 is executed. Next, we shall see to the execution of instruction add LOC, R0. So this instruction will be there in memory, that is loaded from memory into instruction register of processor. Then decoder part of control unit will decode the instruction which is loaded into IR, and it will assess what operation must be done and where are the operands. So one operand is in LOCA, hence LOCA memory address will be put onto MER, that is memory address register, and read signal will be given to that memory location. Hence to LOCA memory location, read signal will be sent by control unit. Then that memory location will put its content on data lines of external memory bus. It is loaded into MDR. From there it is brought to ALU over the internal processor bus. ALU will add LOCA content which is brought with R0 and result is kept back in R0. This is how add LOCA, R0 instruction is executed. Here one thing to be noted here is that different parts of the processor are shown but the interconnection is not shown, but all the parts will be interconnected with the connecting lines called internal processor bus. This processor is connected to memory through external memory bus, but what internally all the parts are connected, they are connected through internal processor bus. The same instruction add LOCA, R0 is accomplished by two instructions. Okay, so first LOCA content is loaded into R1, then ALU will add R1 and R0 register content, keeps the back the result in R0. Okay, so instead of giving directly memory content to ALU, first it is loaded into R1. So R1 is given to ALU and R0, both are added and the result is kept back in R0. Okay, so that is how with these two instructions the same task which was done by the single instruction add LOCA, R0, that is accomplished. So first instruction loads LOCA memory content in register R1. Second instruction adds it with R0 and saves the result in register R0 only. Here the former content of R0, R1 are lost. This is very important. So previously what in R0 and R1 were stored, they will be lost, but memory location content, that is of LOCA memory content, will be retained as it is. So that is all with respect to basic operational concepts of a computer. I hope you understood. Thank you.